All right, let's talk about one of the most high-stakes interviews out there, landing a job as an assistant professor of physics, especially in the Indian college system. If you're gearing up for one of these, the pressure is just massive. So the real question is, how do you do more than just get through it? How do you actually stand out and nail it? Well, we're going to break down the winning strategy right here.
Okay, first things first. We have to clear up the biggest misconception right out of the gate. You might be thinking this whole thing is basically a test to prove you're a walking, talking physics encyclopedia, right? But is that really what the panel is looking for? Is it just a physics exam?
The short answer? Nope, not even close. You've got to think bigger. This interview is actually a holistic look at your entire academic profile. The panel isn't just looking for a brainiac, they're searching for a well-rounded academic. Someone who has the deep knowledge, for sure, but also has a real knack for teaching and a clear vision for their research. It's a much bigger game than just spitting out facts. So to win this thing, you need a solid strategy. We've boiled it down to a really powerful three-part playbook. First, we're going to talk about how to frame your story with a killer intro. Second, how to master those foundational questions to prove you can actually teach. And third, how to showcase your vision by diving into the advanced stuff. So let's kick things off with that all-important first impression. Okay, Pillar 1, your introduction. Look, those first couple of minutes, they are absolutely critical. I can't stress this enough. This is not just a formality. Tell me about yourself. No. It's your golden opportunity to grab the reins of the conversation, make a super strong first impression, and really set a positive tone for the entire interview.
Yeah, this isn't just about being memorable. It's about taking control. A really sharp introduction lets you frame the whole narrative, right from the get-go. You get to guide the interview toward your strengths, your passions, your research. So, how do you build this thing for maximum impact?
Think of this as your blueprint. You're not just going to list off your credentials like you're reading a resume. No way. You're going to weave them into a compelling story. You start with your academic journey, then you pivot to your research passion, you talk about your teaching philosophy, how you approach students. And then, and this is so important, you connect all of that directly to this specific college. You finish up by sharing your vision for the future. This tells them you're not just looking for a job, you want this job. All right, on to Pillar 2, nailing those foundational questions. And believe me, you are absolutely going to get asked questions from the basic, undergraduate, maybe even high school curriculum. But here's the secret. The panel isn't trying to trip you up. They're actually auditioning you as a teacher. The real test is how clearly you can explain a fundamental concept.
Let's take a classic example. Why is the sky blue? I mean, it sounds so simple, right? Almost trivial. But your answer to this question can reveal a ton about you as an educator. So, how do you handle it? Do you just state the fact? Or do you actually build an explanation that makes sense?
So obviously the core concept here is Rayleigh scattering. You've got to get the physics right. That's table stakes. You'd explain how the tiny molecules in our atmosphere are way better at scattering the short wavelength light, the blues and violets, than the long wavelength reds. But just knowing that definition, honestly, that's just the price of admission. It gets you in the door, but it doesn't win you the prize. A winning answer goes way beyond just stating a fact. It proves you can connect a deep, fundamental physics principle to an everyday experience that everyone understands. You're making something complex feel accessible and, frankly, interesting. It shows you're not just a physicist, you're ready to be a teacher.
And here's another perfect example that tests the exact same skill. They might ask you something like, why does a cricketer pull their hands backward when they're catching a fastball? It's a great question because it's rooted in something we've all seen, but the answer digs deep into fundamental physics. See? This is the whole strategy in action. A great answer here isn't about just rattling off Newton's second law. It's about clearly explaining the impulse-momentum theorem. By pulling your hands back, you increase the time of the impact, which reduces the force on your hands. Using a simple, relatable scenario like this to unpack a core principle, well, that's the mark of a great professor. Okay, time for the final pillar. This is where you really showcase your advanced thinking. This is where you prove you're not only a great teacher, but you're also a sharp, capable, and forward-thinking researcher. You've got to show a deep, nuanced understanding of your specific field. So let's say they ask you to compare two different nuclear models. A truly great answer here doesn't just list facts about each one. It shows real nuance.
You'd explain how the liquid drop model is fantastic for looking at big collective behaviors, like fission. But the nuclear shell model is what you need to understand individual quantum states and those stable magic numbers. The key is showing that they're not fighting each other. They're actually complementary tools, two different lenses to understand the same complex thing.
And to really land the point, you can connect it all to the binding energy curve. You can explain that, hey, every nuclear process, whether it's splitting a heavy thing like uranium or fusing light things like deuterium, they all release energy by moving towards the most stable point on the curve, which happens to be iron 56. Thinking visually like this and connecting the dots, that shows you have a real command of your subject.
And then you could just cap it all off with a super clear, simple definition. What is binding energy per nucleon? Well, it's just the average energy it takes to pull one single proton or neutron out of a nucleus. The higher that number, the more tightly everything's packed together, and the more stable the nucleus is. It's simple, it's clear, and it's powerful.
So, there you have it. We've walked through the 3 core pillars of a winning interview strategy. Now, let's just pull it all together into one cohesive game plan that's going to help you secure that job.
Okay, this is your playbook boiled down to 5 key moves. 1. Frame that intro so you're guiding the conversation. 2. Use the basic questions to prove you're a brilliant teacher. 3. Leverage the advanced questions to show off your research chops. 4. And this is huge, always connect your research back to your teaching. And finally, 5, tailor every single answer to that specific institution. You need to show them you're not just qualified, you need to show them you belong there.
At the end of the day, this interview is your chance to do so much more than just recite facts and formulas. So the real final question here is for you. Are you ready to show that panel not just what you know, but who you are as a physicist, as a researcher, and most importantly, as a teacher? Because that's how you land the job.